you have, the quicker the store disappears. So as one goes up, the other goes down. Does that make sense? Okay, so the relationship between horse and hay has some proportion, but it's not, if I do days, horse to days is not directly. How do I write it then? Well, what?
I just said flip.
Flip, yeah, so flip, or if it's inverse, flip, reciprocal, it'd be 1 over. That's inverse, 1 over. As one goes up, the other goes down. So in an opposite relation, if one is multiplication, the other one must be some sort of division. All right, let's look at a specific question. Okay, so it says in this question, z is inversely proportional. Z is inversely proportional to t squared. So I'd automatically write this. So this means proportional. If it's like this, that means direct. But if it's inverse, you got to put it over 1. Okay. But to set up my formula, I still need a k. You can write it like this, or you can write it like that. That's the same thing. To make an equal sign, which is the thing I'll use. In this question, we have an initial set of conditions where z is 4 and t is 1. And this will help me find what k is. Again, simple equation, I think. If z is 4 and time is 1, k must be 4, right? You happy with that? K must be 4. So I have a new, the equation I'll use is z is equal to 4 over t squared. That's the one. So before starting any of these questions, you need to get what that k is. Now I'll use that to finish the question. Find z when t is 2. Looks a lot easier when I have this formula to use. So z is 4 and 2 is, so that's 4 over 4, which is 1. How would I do that? No, don't do that yet. No. You could factor out, you could square root if you needed to solve it a different way. I see what you're doing. You're trying to almost solve it. You don't need to do that. Yeah. And the last one then, find in the opposite way, find t when z is equal to, what's that, 16? Okay, so in the opposite way, if I know what z is, it's 16. And I know 4 over t squared. I could square root at this stage. It's probably easier to do a quick cross. So I get t squared is 4 over 16, which is t squared is equal to 1 over 4, t squared. What's t then? What's the square root of a quarter? Square root. Okay, so t would be root 1 over 4. So it would be 1 over 2, but it would be plus or minus. Could be plus or minus. It could be the same answer. The root of 1 is 1. Yeah, and the root of 4 is 2. That's where it comes from. So root 1 over 4, using our rules of surds, which you may have forgotten. The square root of 1 is 1, and the square root of 4 is 2. But it has to be plus minus if we're square rooting. It could be either option. Okay, and the last thing to discuss then is the shape. If we ever saw it on a graph, what would it look like? Predictions of what it would look like? It would look amazing, obviously, yes, because it's maths. Okay, well, we already said that it wouldn't, in direct, it has to go through 0, 0. But in direct, that would just be a negative k. and it would be straight line down.
It would be going like,
Well, what does a rational function look like when y is equal to 1 over x? Or y is equal to x plus 2 over x minus 3 or something like that? It's not going to be a straight line. You can even see from our horse and days example, if one horse 24, two horses 12, three horses 8, four horses 6, and so on. What's 5 horses? I know this is not as easy to divide into. Yeah, let's pick another one. If we had 12 horses, what would it be? 2. So notice the rate of decrease here. What's the rate of decrease? Is it constant? No, because if I had 24 horses and went way down 24, we'd only be at 1, wouldn't we? So it's slowing down. The rate of decrease is slowing down as we go. So what would that look like? Yeah. And if you kept on, you'd have 48 horses, would take half a day. And so on. So if we looked at the shape of that shape, one started off pretty high, and then as we get closer, we start flattening out. And that's the classic shape of a rational function. Maybe you might recognize that. We have this on the other side then. This one would probably be ignored in these results because you can't have negative horses and negative days. So you would stick with the positive side. So that would be the look of one of these proportions. Would it cross the x-axis, this one? No. You get pretty close. If you had 1 billion horses, it might take a millisecond to eat all the hay, but no matter how many horses you have, you'll never get a negative number of days. Make sense? And if you have 1/100th of a horse, it would take him a while. Like a midget horse, it would take a really long time for the days. Okay. All right, so what work do we have? Primarily, your homework for Monday will be My Maths. That's the only thing I'm going to check. Once you have your My Maths done, you can focus on the worksheet I have on direct and inverse, which I have the answers for already, so you can check as you go on that. So I'd probably get started on My Maths, and then finish that, do your the worksheet's on Manage Back. The worksheet split standard and extended.